Okay, so let me share my screen first. Can you see my screen?
Yeah, we can see.
Yes, sir.
Okay, okay. Okay, so let's start with the digital comparator. So this is one of the combinational logic circuits where two numbers are uh, given at the input of the circuit. So it can be an n-bit number. Let's say there are two A and B. Both can contain n number of bits, and the circuit will compare these two numbers, digital numbers, whether A is greater than B, or A equal to B, or A less than B. So in the experimental scope, we will discuss about only 1-bit comparator and 2-bit comparator. So 1-bit comparator means A can be of 0 or 1 and B can also be of 0 or 1. So let's see the 1-bit comparator. So the truth table of 1-bit comparator looks like this. So 0 when A equals to 0, B equals to 0 and 1, and when A equals to 1, B equals to 0 and 1. Let's say that when A equals to B, that means when A equals to 0 and B equals to 0, or A equals to 1 and B equals to 1, you can see that in the truth table, A equals to B column will get 1. Otherwise, it will be 0. When A is less than B, that is for one case, this one, when A equals to 0 and B equals to 1. So for that, A less than B will be 1, otherwise it will be 0. And for A greater than B, when A equals to 1 and B equals to 0, so A greater than B will be 1. So this is the truth table of a 1-bit comparator. Now, how you can design the circuit that I have shown in that block. Um, if you take that A greater than B term, you can see only 1 is coming for A equals to 1, B equals to 0. So we can express this in the product form, that is A B bar. So A greater than B will be A B bar. That means A will be directly fed to an AND gate and B will be inverted using one inverter. So here you can see for AND gate number 2, so A is coming directly and B is getting inverted, then going out of this. So if you take the output from this number 2 AND gate, you will get A greater than B. Now for A less than B, you can see when A is low and B is 1. So for that, again, we can write it in a product form of A bar B. Here, A is inverted, but B is directly connected to the AND gate. That is AND gate number 1. If you take the output, you will get A less than B. Now, when A equals to B, you will have two conditions. That is A bar B bar plus AB. You can uh, write it in a sum of products form, and in this circuit you have that A B bar term at this point, number 2 output, and A bar B term in number 1 output. If you put this in a NOR gate, you will get A equals to B. Some Boolean function will be coming, and you will get A bar B bar plus AB at the output of number 1 NOR gate. This is the 1-bit comparator, and this circuit is given in the VLab. So let's see first in this. Let's see the second one, that is 2-bit comparator, and then we will go to the VLab simulator. So now for 2-bit comparator, so you can see that the term A can be of bits 00, 01, 10 or 11, and beyond B will be also be of 2 bits 00, 01, 10, 11. Now there are number 4 bits, that means 2 to the power 4 kind of combinations can come from these 4 bits. You can see that 00, 00, 00, 01 to 1111. Now each of these numbers A and each of these numbers B will be compared, and then A greater than B or A equals to B and A less than B output will come. So for this case, A greater than B term will come here, because here A is 101 only and B is 00. So that's why this part is A greater than B. So it is 1. Now again see where A greater than B 1. Here. Here A is 10, that means 2, and B is 00. So for this case also A is greater than B, then it is 1. Next case, that is A equals to 2, 1, 0 in binary terms, and B equals to 0, 1, this 1. Here also A greater than B. In this case, A is 1, 1 and B is 0, 0. That means A is 3. If I convert it into decimal, so also it will give you A greater than B. There are other terms also. So likewise, you can also find out where A equals to B. And you can put 1 in this case, and also you can put A less than B. Okay, so similarly, like 1-bit comparator, you can express the terms A greater than B in a sum of products term. A equals to B also like that, and A less than B. So let us first see that what are the terms you can find. So for A greater than B, the term will look like this. For A equals to B, the final term will be looking like this: A naught, X naught, B naught, or into A1, X naught, B1, and A less than B in terms of this sum of products form. Now, in the circuit, you can directly design the circuit using NOR gates, and sorry, using inverters, this AND gate, NOT gate, then AND gate, and NOR XNOR gates for A equals to B. So if I take the first one, A greater than B, so this term comes like A1 B1 bar. Now A1 B1 bar, let's say this is A1, this one is B1, and this is B1 bar. Now A1 B1 bar is coming in this AND gate. So A1 is coming and then B1 bar is coming. Now the second term, that is A0 B1 bar B0 bar. So A0 is directly coming, B1 bar it is taking from here, and B0 bar is taking the second term in the sum of products form is coming from this AND gate. And the third term, that is A1, A0 and B0 bar. So A1 is coming directly here, A0 is also coming, and then B0 bar, the bar term is coming from here. So the 3 product terms are coming from these 3 AND gates, and then it is summed using a 3 input OR gate to get the logic function of A greater than B. Likewise, for the second one, that is A0, X0, B0 and A1, X0, B1. So here also A1, A0, X0, B0. So these 2 inputs are going to X0 gate and coming from this one, and the second term is coming B1, A1, X0, B1, and this is coming, and then again it is going to 2 input AND gate to give you the logic function of A equals to B. The same way the A less than B also coming. So this is how you can implement a 2-bit comparator using these AND gates, NOT gates, OR gates and XNOR gates. Let's see the simulator how it works. Okay, so here is the one. Let me start from the beginning. Uh, you can go to the VLabs IIT Roorkee website, and then in the list you will get Digital Electronics Lab 1. If you click on that, the many experiments will come out like this. If you go into the list of experiments, and then you can find the 1 bit and 2-bit comparator using logic gates. And if you click on it, you will get this page. So let's go to the directly to the simulation page. So for 1-bit comparator, clicking on that, the circuit that I have showed in the 1-bit comparator case, let's say this one where two NOT gates, two AND gates, and one NOR gate is used. So let's go here. There is a NOT IC, inverter IC 7404, AND gate IC, it's 2 input AND gate 7408, and NOR gate IC 2 input 7402 are used, and directly and the connections are made using that diagram. So now I am just turning on the IC power. The power is on. Here you can see A and B both are switched off. That means in magnitude both are equal. So that's why A equals to B LED is turned on. So you can add this in the truth table like that. When 00, it is 1. Now let me turn on the B. So here A is less than B. So that's why this second LED, which comprises A less than B, is turned on. You can add the truth table here. Then I am changing the condition where A greater than B. A is 1, B 0. So you can see this LED turns on. Then at the truth table you will get that when A equals to 1, B equals to 0, so A greater than B will come out as 1, and then again both are 1. Then same, this last one, that is A equals to B, will turn on, and you can add this in the truth table. So this is how you can directly verify the 1-bit comparator truth table using this VLab. Now moving on to the second one, this 2-bit comparator. So here the 2-bit comparators, you can use 6 to the power 4 cases for your comparators truth table as shown in the PPT. So the same circuitry is there that I have shown in the PPT for 2-bit comparator. The connections are made like that, and again these 3 LEDs are used for the indication purpose when A equals to B or A greater than B and A less than B. So let's start with this power. So let's turn on it. Now I am taking all A1 A to be 0. That means these switches of A1 and A0 will be turned off. And if I turn on any of the switch here like that, you will get A less than B. Now you can add it here and you can verify that. Now let me turn on one of the A switch. Let it be A1. A1 is 1, A1, A0 is 0. So you can see that A1, A0, it is 1, 0, and B1, B0, it is 0, 1. That means A is greater than B, because A corresponds to 2, decimal digit 2, and B corresponds to 1. So here A greater than B LED is turned on. You can add that and you can verify it is A greater than B. Now again, I am turning on A not 1 and it will also be greater than this B. So this LED is turned on, you can add it. So likewise, you can get 16 combinations using these 4 switches. So to verify this, I would suggest that you go by the truth table, that like keeping one constant like A, let it be 0 0 and then change the combination of B and you will get the logic functions of A greater than B, A equals to B, A less than B. Then change it to second state, that is 0 1, keep it and change the B accordingly 0 0 0 1 1 0 1 1 and then take the logic function from here. So this is how you can do it in the tree labs section also. So this is the part of magnitude comparator. So if you have any question, so you can ask me. Otherwise, Vishal will take over from here.
Sir,
Yeah,
sir, is the link given in the guidelines PDF for IIT Roorkee Visual Lab?
yeah, yeah.
Yeah, yeah.
Okay, sir.
Do you have any questions for Anirban? Students? Otherwise, Vishal can take over. Yeah.
Okay, so let me stop. Is it stopped? Okay.
So is it visible?
I can see a screen. Hello.
Okay. Is it
Yeah,
Vishal
it is,
presenting?
Yeah, I think Vishal is presenting.
Okay, okay, fine.
Latches, yeah.
So now we will see what is latches. So am I audible?
Your
Hello?
voice is not clear. Maybe the mic is far away or something.
So now it is audible.
Little better, but it seems like you are kind of inside some cave. Okay, but anyways, yeah, try to speak a bit louder.
So latch is a nothing but it is also one kind of logic circuit. It is a storage device. It stores one bit information. It is also called bistable multivibrator because it has a latch has two storage states. One is high output and another one is low output. So there are different types of latches we have. The first one is SR latch, and then gated SR latch, then D latch, gated D latch, a JK latch, and D latch. So now we will see the what is SR latch. SR latch this S is here S stands for a set and R stands for reset. So in digital circuit, if I say reset, it means the output is equals to 0. So we have reset it our circuit. And if I say set, then the on that time the output is equals to 1. Means if we make our input R equals to 1, then output Q is becomes 0. And if we make the input S equals to 1, then the output Q becomes 1. Now I am going to analyze this circuit for different cases. So let's see the first cases. So when the input is 0 0, let's say R is 0 and S becomes 0. On that time we can see in the truth table the output Q1 becomes Q1 minus 1 and Q1 is Q1 minus 1. Means basically it says that it holds the previous state. Let's say when the present state output becomes 0. So here there are two feedback parts. So one feedback path is the output of this NOR gate is feed input to this NOR gate, and output of this NOR gate is feeded input to this NOR gate. So let's take the present states. Q becomes 0. So when Q this output 0 is feeded input to this NOR gate, when the input of NOR 2 input NOR gate is 0 0, then the output becomes 1. And when this input or this output 1 is fed to this uh, input to NOR gate, when we all know that when any input of NOR gates is 1, then the output becomes 0. So here we can see that it's nothing but it holds the previous output, that is 0. So when the input becomes 0 0, then it holds the previous output, that is whatever we take. So here is no change. It also stores the previous information, that then we can also say that it is a memory state. So when we take input 0 1, when we take input is reset, R is 0 and S is 1. So we can already say that when we take S is 1, means set is 1. So when the set is 1, then the output Q becomes 1. So let's verify it. So when the S is 1, then the input of, when any input of NOR gate becomes 1, then the output is 0. So this 0 is fed here. So here R is 0. So 0 0. When the inputs of two NOR gate, when the input is 0 0 to this NOR gate, then the output becomes 1. So when the set is 1, then now we can get the output is 1. So let's see the third input when the R becomes 1 and S becomes 0. So here we take the input R is 1 and S is 0. When the R is 1, that means that here the output is 0, means it resets the circuit. So let's verify this. So here the input 0 is coming here, and here S is also 0. So 0 0 becomes the output of this NOR gate is 1, and when 1 is fed here, so here the output is, when any input of NOR gate is 1, then the output is 0. So let's discuss the last state. When the both the input is 1, then we can see in the truth table this is invalid outputs, which means to say that when we take the both the input is 1, that is R is 1 and S is 1. So here we can we know that when the any input of two NOR gate is 1, then the output becomes 0, and here is also output becomes 0. So here we can see this is contradictory statement, because here we have the output Q and this is the Q complement, but we get the output that is same 0 and 0. So these are the invalid outputs. So let's see this overall operation in GLab. So first we connect the power supply. So now because battery is connected to the circuit, so when we take the input, that is both set and reset is 0. On that time, we can see in the output there is no change. It holds the previous state. When we set the circuit, then the output becomes 1. When we reset the circuit, that is R is equals to 1. On that time, we can get the output becomes 0. When we take both input is 1, on that time, it shows that there is invalid output. Means there is invalid output. So that's all from my side.
Yeah. You done?
Yes, sir. If you have any doubt.
There's some disturbance from your side. Anyways, yeah. Any questions from the students to both the TS? Any questions? Okay, if you don't have any questions, I need a input from you all. So as far as I see in the ERP, Monday afternoons you don't have any classes, right? Monday afternoon you don't have any class. So if we conduct your test on a Monday afternoon, that should not be a problem, right?
Sir, we are having a
Students?
test on 1st November, that Monday. Other than that, it is fine.
Okay, so there is no usual classes, but you are having a test on 1st November, right? So you are okay with 8th November then. 8th November, you can have a test on 8th November, right? Monday slot around, yeah, we'll start at 2 or 2:30 maybe, that we'll let you know. But in the afternoon slot, right? So there is no problem with that. November 8th.
Yes.
So problem from the point of view of clash, okay? Don't say that you won't be prepared or you have another exam or something like that. Okay? You don't have any clash, right? So no answer means I would take that, yeah, there is no class. Okay?
Yes, sir, there
So
is no
fine.
clash.
Okay, fine. So we will be having your test on 8th, okay, and all the modalities and details about that we will share with you through an email, okay. So yeah, so be rest assured it will be on 8th, okay. So 8th afternoon, so it's on Monday, not Tuesday. Again, on Monday 8th afternoon we will be having, okay.
And sir, on which platform we will have a
we
test?
will let you know that,
Okay.
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 So everything that is still undecided, okay, so we'll let you know once it is decided, okay. Okay, so anything else you want to ask?
Sir,
So
what
the
will be the
deadline,
deadline of this level?
yeah, deadline, yeah,
Six-
deadline for this assignment, the final this thing, already half of that is already covered like 3 weeks ago, 2 weeks ago. So we will have next week, okay. So next by next Tuesday, which is the 2nd of November. So also the TS, please note 2nd of November the deadline, okay, for submission of this particular assignment, last an assignment related to the 6th experiment.
Sir, please try to do it by 9th November, sir.
9th will be too late. We have to evaluate as well. Okay. So 9th would be too late. Maybe we can think of 5th or something like that. 5th of November. Okay, 1 day or 2 day.
Yes, sir.
Late.
Sunday means Saturday or Sunday.
Till 10
Okay. Anirban, then make it 6th. Okay, 6th November. Okay, so neither Friday nor Sunday, Saturday. Okay, 6th November you make the deadline, and
Okay,
let that be hard deadline as well. Let that be
Yeah,
hard
yeah.
deadline as well. Okay, 6th. Okay, so they are asking, they are having some tests, so it's fine. So we'll have it on 6th November, right?
Okay, sir.
Okay. Anything else you want to ask or anything you want to discuss? So again, 6th November will be deadline for this, and 8th you will have test. Okay, so please note down it's on Monday, not on Tuesday. Okay, don't come on 9th. We'll send a mail. Okay, so still, I mean, there would be 1 or 2 who will be saying, no, we didn't know. Okay, please don't, we don't want anybody like that. Okay.
Sir,
Yes.
so in the test, the syllabus would be all the experiments we have done till now.
Yes, all the experiments from the first and mostly experiment related. But when we are sending you mail, every instruction will be there. We'll be talking about syllabus. We'll be talking about the amount of time, okay, the time of the test, and also we'll be talking about the modalities, like where you will be conducting, where the test will be conducted, and everything. Okay, we'll tell that. But yes, of course, like all the 6 experiments and more on the practical point of view, okay, rather than theories of them. Okay, more concentration will be related to the experiments. Okay, and of course, some videos were shared in early stages by Professor Bhattacharya. So those videos also please go through them. Okay. Yeah. Anything else you want to ask? Professor Bhattacharya, you want to add anything?
I think it's fine. I mean, like as you mentioned, please come on Monday, not on Tuesday. That will be a big mess otherwise. There is nothing else to add from my side.
Yeah. So then if we don't have any other questions from the students or any other clarification, need for clarification, then we'll conclude the lab. Okay, so we are done with the labs then. Okay, please submit within the deadline the final assignment on the 6th, and on the 8th we have test again. Okay, so bye bye. Yeah, any
So
question?
finally, no classes from the next week, right?
No more classes. That's it. This is the final class.
Thank you so much.
There's nothing else. Yeah. Okay. Thank you. Bye bye then. Yeah.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thanks everyone for joining. Thanks.
Thank you, sir.
Thank you, sir.